Hi everyone, welcome to mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 1, which is a pure mathematics one for February-March 2022, and the code is 9709/12. So let's move on to question number 1. Okay, question number 1, a curve with equation y equals to fx is such that f prime x is 2x to the power of negative 1 over 3 minus x to the power of 1 over 3. It's given that f8 equals to 5. Find fx. Okay, so from here, I will rewrite the f prime x first. So f prime x is the gradient of the graph. Okay, so to get the fx from f prime x, basically we need to integrate. So fx is integration of 2x to the power of negative 1 over 3 minus x to the power of 1 over 3 dx. So when we integrate with the function with respect to x, we are actually adding the degree of x by 1. Okay, so here becomes x to the power of negative 1 over 3 plus 1, it will be 2 over 3. Then divided by 2 over 3, then minus x to the power of 1 over 3, you plus 1, it becomes 4 over 3. Then divided by 4 over 3 and plus c. Now, I will simplify the constants first. So 2 divided by 2 over 3 end up with 3. So first term becomes 3x to the power of 2 over 3. Then the second term, 1 divided by 4 over 3, it becomes 3 over 4. Okay, that is our fx. So now it's given that f8 is 5. So now f8 is 5, which means 5 equals to 3, then the x is 8. So replace the x by 8, then the power 2 over 3 minus 3 over 4 times 8 to the power 4 over 3, then after that plus c. So when you count the values, the first one is actually 12, the second value on the right hand side is also 12, then plus c. So obviously our c now is 5. Okay, therefore just need to substitute into the into this expression, and then you will be getting the fx. Okay, so this is the solution for question number 1. Okay, now let's move on to question number 2. A curve has equation y equals to x squared plus 2cx plus 4, and a straight line has equation y equals to 4x plus c, where c is a constant. Find the set of values of c for which the curve and the line intersects at 2 different points. So since they're intersecting, means that now we have to solve these 2 simultaneous equations. So I will let y equals to x squared plus 2cx plus 4 be the first equation, and then the y equals to 4x plus c be the second equation. Since they're intersecting, means that first equals to second equation, right, which is the intersection point. Now, I will be getting x squared plus 2cx plus 4 from the first equation, that equals to 4x plus c. Then now, just move all the terms to the left-hand side. Then I will get x squared plus 2cx plus 4 minus 4x minus c equals to 0. And now here I will simplify first, right? So it will be x squared plus, now for the x, here 2cx, here is minus 4x. Therefore, I can factorize the x. Then the coefficients will be 2c minus 4. And the remaining constants will be 4 minus c. That equals to 0. So now, since it's mentioned that they are intersecting at 2 different points, which means that the discriminant will be greater than 0. Okay, so now before I use the discriminant method, then I will write down the coefficients for all the terms first. So the coefficient for x squared is 1, coefficient for x is 2c minus 4, and then the coefficient for, the constants will be 4 minus c. Okay, so discriminant is b squared minus 4ac. Now it's greater than 0 because of 2 intersection points. right? Two distinct points. So here, where I replace, I will get 2c minus 4 squared minus 4, 1 times 4 minus c is greater than 0. And now, by doing the expansion of the quadratic, so we have a formula here. Square of a plus b is basically a squared plus 2ab plus b squared. Okay, so now when you square the 2c, you'll be getting 4c squared. Then the 2ab here will be 2c times negative 4, that is minus 8c. Then you times another 2, so it becomes minus 16c. And followed by square of 4, it will be 16. Now, here will be negative 4. Then you do expansion, it will be negative 16. Then plus 4c greater than 0. And now I simplify. So I will be getting 4c squared. And then when you look at these two terms, right, negative 16c plus 4c is basically negative 12c. So here I will write negative 12c. Then now, okay, these constants will be cancelled off because one is plus 16, another one is minus 16. So now I will be getting greater than 0. And then from here, 4c squared minus 12c greater than 0, the common term is 4c. So I will factorize 4c, then you will get c minus 3 is greater than 0. Okay, now, when we need to solve this quadratic inequality, we always refer to this graph. So now, when you look at the coefficients for c squared, it is positive 4. That means this graph, when I sketch this graph, it will be having a minimum point. So now, my x-axis, now my horizontal axis instead of x now becomes c, because your quadratic equation in terms of c, or quadratic inequality in terms of c. And then, when I look at the next step, okay, I need to find the intersection with the c axis. So I will let this be 0. That means your c is 0. And when I let this bracket be 0, the c is going to be 3. So then, when I will label here as 0 and 3. Okay, and now, the region is based on this, the last part. So the graph is greater than 0. Greater than 0 means that it is above the c axis, which means now your c is less than 0 or c is greater than 3. Okay, so that's the solution of this question. Now for question 3, find the term independent of x in each of the following expansions. So the first one is degree 6 of 3x plus 2 over x squared. So I will write 3x plus 2 over x squared to the power of 6. This is actually same as summation 6r. Okay, 6r means 6cr. 3x to the power of r. Then 2 over x squared to the power of 6 minus r. So the r starts from 0 until 6. Now, from here, we need to get term independent of x, which means now I have to split all the terms. I bring in the power r. So here will be summation r from 0 to 6, then 6cr, 3 to the power of r, x to the power of r. When I expand, I will bring in the degree, right? Then this part, 2 over x squared, I will write 2 to the power of 6 minus r because I bring in as well. But then the x squared is at the bottom here, which is the denominator. Then I will move up. So once you move up, the degree becomes negative. So this is what we get. Alright. Now here, I will write down term independent of x is basically referring to x degree 0. So when x degree is 0, then now I will just compare the terms on the right side for the terms with x, the base x, right? So I will get x degree r multiply with x degree, this negative 2 times, because we have a formula here. If a power m, then another degree n outside, you can just bring in. Alright, so now here I will get minus 2 times 6 minus r. And now I will compare. When you have multiplication of two same base, let's say a power m times a power n, it will be a to the power of m plus n. Okay, so now I'm going to add the 2 degrees. So here becomes x r plus this one bring in. So it will be negative 12 plus 2r. So it will be x degree 0 on the left hand side. Now I will just do expansion. I will just do comparison. So 0 equals to r plus times minus 12 is minus 12. Plus times plus 2r is plus 2r. So from here I will get 3r minus 12 equals to 0, which means my r is going to be 4. So which means the term independent of x happens when r equals to 4 in this whole expression. Alright, so when r equals to 4, term independent of x is going to be 6c4. Okay, just substitute into this expression. 3 power 4, 2 to the power 6 minus 4. Alright, so when you calculate this, it should be 4860. So that's the solution of this question. Okay, now B. You need to get the term independent of x for the same expression just now, but then multiply with 1 minus x cubed. Okay, so here I will rewrite the question. Then now here I will do expansion. So this is same as 3x plus 2 over x squared to the power of 6, then minus x cubed times 3x plus 2 over x squared to the power of 6. Now, for the first one, we already done it just now. Okay, but then now we just need to solve for the second one. Okay, so for x cubed 3x plus 2 over x squared to the power of 6, this is basically same as, now look at here, x cubed is just one term. Therefore, I will just rewrite this, right, by referring to the previous. Because if it is power 6, then you'll be getting 7 terms. Alright, so I will copy this and multiply with x degree 3. So it will be summation 6r. Right, this whole expansion, I will not rewrite this, but I will just refer to this simplest form. Okay, the one that has been expanded. So I will write 3 power r x power r. After that, 2 to the power of 6 minus r, which is here. Then you get x to the power of negative 2, then outside 6 minus r. Or I will say that x to the power of the minus 2 and 6 minus r, this is basically minus 12 plus 2r. Okay, so I will just direct simplify. Then the r from 0 until 6. All this belongs to the power 6 of the two terms. But don't forget you still have x cubed. So I multiply with x cubed. Right? So then from here, I will get summation r from 0 to 6, 6 power r, 3 power r, then it will be x to the power of r minus, okay, now I need to simplify all this, r minus 12 plus 2r, then plus another 3. Okay, and then followed by 2 power 6 minus r. And then now, x degree 0 means term independent of x. So it will be x to the power of r minus 12 plus 2r plus 3. So here 0 equals to, now when you compare, this r and plus 2r becomes 3r. So I will get 3r. Then now, minus 12 plus 3 is going to be minus 9. So I will write minus 9. So from here, your r is going to be 3. Okay, so I will say term independent of x in x cubed 3x plus 2 over x squared power 6 happens when r equals to 3. So now I will just replace the r value in this expression. Alright, so here I will write this is equals to 6c3 3 power 3 times 2 power 6 minus 3. Okay, so this is going to be 4320, just for the second expansion. Now don't forget, your original question has one more term in front. So now what I will do here is, I will just continue here, right? So term independent of x in 3x plus 2x, 3x plus 2 over x squared power 6 multiply with 1 minus x cubed. Right? So it's going to be the previous answer. So the previous answer is basically 4860. Then minus, because I have split it into two terms and it is minus. Right, this is minus. Then 4320. So here you will be getting 540. Alright, so that's the solution of this question. Okay, question number 4. The first term of geometric progression and the first term of arithmetic progression are both equal to a. Okay, so now the third term of the geometric progression is equal to second term of the arithmetic progression. Now, this means third term of geometric progression. So for geometric progression, the formula is AR n minus 1. For arithmetic progression, it is a plus n minus 1 d. Okay, so since the first term is a for both, so I will just use a. Then now the r is a common ratio and the d is a common difference for the arithmetic progression. So now when third term, that means T3, then I will get AR squared, right? Because your n is 3, equals to second term of the arithmetic progression. So you will be getting a plus 1d because your n now is 1. Is 2, sorry, is 2. Okay, so now from here, right, you get this equation. I leave it first. Now the fifth term of geometric progression means that AR degree 4 equals to sixth term of arithmetic progression, which is a plus 5d. Now given that the terms are all positive and not all equal, okay, find the sum of first 20 terms, which is S20, of the arithmetic progression in terms of A. Since we need the answer in terms of A, means that we need to eliminate the D from the simultaneous equations, right? Or probably my answer will in terms of A, so no more D. You need to find what is a D. So from here, right, I will get the D as a subject for the first equation. So now my D is going to be AR squared minus A. This is my first equation, and this is going to be my second equation. Now I substitute first into second. So left hand side it will be AR degree 4. Right hand side the A remains 5D. So the D will be replaced by AR squared minus A. And then here I will do expansion. AR degree 4 is A plus 5AR squared minus 5A. So now I move all the terms to the left hand side. Then you will be getting AR degree 4, okay, minus 5AR squared. Now when you look at the right hand side, this is A, this is minus 5A. So when you get the total, it will be negative 4A. So this negative 4A move to left hand side, it becomes plus 4A. Then equals to 0. And now I notice that all the terms on the left hand side have A. Then I can just divide the whole equation by A. And you will be getting the equation in terms of R squared. So this equation in terms of R squared can be factorized into two linear factors. So the first linear factor is R squared minus 4. And then the second linear factor will be R squared minus 1. Okay, because normally you'll be given the quadratic equation. So now instead of the x in the middle term, now your x has been changed to R squared. Okay, so you just change accordingly. for this factorization. Now from here, I will be getting r squared minus 4 equals to 0, or r squared minus 1 equals to 0. Then the r squared is equals to 4. Here, r squared equals to 1. So we know that for geometric progression, r squared, if r squared equals to 1 means that r equals to, you'll be getting the same number, right? Therefore, it's mentioned that all the terms are positive, alright, and not all are equal. So now r squared equals to 1 will not be accepted. Okay, because when r equals to 1 means that all the terms will be the same. So here will be omitted. Okay, and the r cannot be negative. If your r is negative, then you will not get positive anymore. Alright, so now I will be getting r squared equals to 4. That's my conclusion for the r squared. Now, I need to find the S20 in the arithmetic progression. Means that I need to know the d. Alright, so now from the first equation, I can find the d. So from first, my d is AR degree 2 minus A. So AR squared minus A, which means now my R squared is 4. So I will get 4A minus A. So then my D is 3A. So after you have found this, then we can easily find our S20 in the arithmetic progression. So Sn is n over 2, 2A plus n minus 1 D. This is for arithmetic progression. So now S20 is 20 over 2 times 2A plus 19D. D is 3A. So then from here, 20 over 2 is basically 10. Right? So all the terms inside the bracket, you just need to times 10. Then from here, now the 2A, this is basically 19 times 3A plus with 2A. Then you get 59A. So I'll get 10 times 59A. Then at last, it will be 590A for the S20. Right? So that's the solution of this question. Now, for question number 5, express the quadratic function in the form of 2 times square of x minus a plus b. So this is done using completing the square method. So 2x squared minus 8x plus 14 equals to, since your b plus b is inside the brackets of 2, that means I will factorize 2 from all the terms. Then you will get x squared minus 4x plus 7. Then now, rewrite the first two terms. And then for completing the square, you always plus bracket squared minus bracket squared. Then plus 7. Now the term inside the bracket, it should be this coefficient, the coefficient for x divided by 2. So I'll get negative 4 over 2. Then here, also negative 4 over 2. Alright, after you get this, what to do is you just group the term with the green line. Alright, so it means that here I will get 2 bracket x. Now, for the bracket, minus 4 over 2 is basically minus 2. So I will just write minus 2, then squared. And now here minus, okay, this is minus. Then inside the bracket is minus 2. Then you square it and plus 7. Then at last you'll be getting 2 bracket x minus 2 squared. Now, when you count the total of these two terms, you will be getting plus 3. So that's the required answer in this question. Right, now the functions f and g are defined by fx equals to x squared for real number of x, gx is a quadratic for real number of x. Now describe fully a sequence of transformations that maps the graph y equals to fx onto the graph y equals to gx, making clear the order in which the transformations are applied. So basically, your fx changed to gx, right? Fx transform onto gx. Now, your gx, okay, we have solved just now. 2x squared minus 8x plus 14, which is here, then I will start with this expression, the completed square form. So now my gx is 2x squared minus 8x plus 14. This is same as 2 of x minus 2 squared plus 3. This is from the previous part. Alright, so from here, I will say that now your fx is just x squared. So when you look at the x squared here, x squared has been changed to this. Alright, that means I will say x squared change to or transform into x minus 2 squared. At the same time, I consider a plus 3. So it means that the x here has been changed to x minus 2. Okay, and then at the same time, the plus 3 is on the effects of the y values. So this is a translation of 2 and also 3. Okay, the 3 is on the y-axis, the 2 is on the x-axis. Now, later on, I consider the 2 at the back here, I mean in the front here. So I will get 2 times x minus 2 squared plus 3, means that this is the effect on the y values now, the whole graph, right? So this is basically the stretch. Stretch in the y direction with factor 2. Okay, because there is a 2 here. Alright, so if you want to write down the sequence of transformation, so I will say that transformation, okay, this is a transformation. It will be translation two in the x and 3 in the y-axis, followed by the stretch in the y-axis, in the y direction, with factor 2. So this is our full transformation. Alright, so that's the solution of this part B. Now, for question number 6, the circle with equation, okay, this is a circle equation, and the straight line with equation y equals to 3x minus 20 are shown in the diagram. The line intersects the circle at 2 points, A and B. These are the 2 points. And the center of the circle is at C. This is the center. Now, find by calculation the coordinates of A and B. So obviously, A and B are the intersection points between the circle and the straight line. So now I need to solve the intersection points, which means I need to solve the simultaneous equations. So now I will just write down x plus 1 squared plus y minus 2 squared equals to 85 as first equation. Then my y equals to 3x minus 20 as the second equation. To solve simultaneous equation, I will just substitute second equation into first equation. Which means I will replace my y by 3x minus 20. Okay, now before I do expansion, I will simplify the second term on the left hand side first. It will be 3x minus 22 for the term inside the bracket. And then from now, okay, from here, I will expand it using quadratic expansion formula. So square of a plus b is basically a squared plus 2ab plus b squared. And then now, by using the binomial, the quadratic expansion formula, I will be getting x squared plus 2x plus 1 for the first squared. And then the second square, it will be 9x squared minus 132x plus 484. Your square of 22 is 484. This 85 will be moved to the left hand side because negative 85 equals to 0. Now, simplify all the terms. X squared plus 9x squared, it will be 10x squared. Alright. Then here, 2x minus 132x, it will be negative 130x. And then for the rest of the terms, 1 plus 484 minus 85, then you will get plus 400 equals to 0. So from here, you can divide the whole equation by 10. Then I will be getting x squared minus 13x plus 40 equals to 0. It is a quadratic equation. And now I'm expecting to get two x values because there are two intersection points. Okay, so when you do factorization for this quadratic equation, you will be getting x minus 8 and x minus 5 for two factors. Then from here, x minus 8 equals to 0 or x minus 5 equals to 0, which means your x equals to 8 or x equals to 5. Okay, two x values. Now, obviously, x equals to 5 belongs to B and x equals to 8 belongs to A. Okay, and now we need to find the y coordinates. So the y coordinates belongs to can be found using y equals to 3x minus 20. So now, when x equals to 5, y equals to 2x, y equals to 3x minus 20. That means it becomes 3 times 5 minus 20. So this is going to be minus 5. When x equals to 8, your y is 3 times 8 minus 20, which is 4. Therefore, now I will write A is basically with the greater x. So it's 4. That will be the points of A, and the B will be 5 and minus 5. Okay, these are the 2 points that we have just found. Now for B, find an equation of the circle which has its center at C and for which the line with equation, okay, this is the equation, is a tangent to the circle. So now I need to find the center at C first. So the center at C, right, it is the same as the equation. So from here, I need to get the center. So I'm going to rewrite. So it will be x plus 1 squared plus y minus 2 squared equals to 85, sorry. For your information, circle equation, it will be always x minus a squared plus y minus b squared equals to r squared. Then the circle will be having the center with coordinates a and b. Okay, then the r is the radius. This is the radius. Alright, so now I need to get the similar form, which means here it will be x minus 1 squared plus y minus 2 squared equals to 85. That means now here, my center, which is a C, is with coordinates minus 1 and 2, based on this general formula. Now, you need to find the equation of the circle, which has this center, and this line is a tangent to the circle, which means now, when you refer back to this, right, so now, most likely, this is a tangent to the circle, means that the I would say probably you are getting like this. Okay, let's say this is a circle that you need to find. Okay, because the straight line is a tangent to the circle now. So from here, I need to find the intersection points. Okay, because I need to find what is the R. How much is the R here? Okay, so what we need to do here is I need to get the intersection points between my new equation. Okay, so my new circle will have the equation of x plus 1 squared plus y minus 2 squared equals to r squared. I do not know how much is the r. That's why now I need to find. Okay, then at the same time, this is also intersecting with the straight line at one point, so that it will be a tangent line. Alright, so now I will say, let's say this is the first equation, then the y equals to 3x minus 20 is the second equation. Now I need to solve the simultaneous of these two equations and make sure only one point. Okay, so now I substitute second into first, then I will get x plus 1 square plus, okay, so when you replace, so this is going to be 3x minus 20, then minus 2, which is 3x minus 22 squared equals to r squared. Now, for your information, these two terms we have done just now, okay, for the quadratic expansion, is exactly the same, which means I will copy all these terms up to here. Alright, so then I will get x squared plus 2x plus 1 for the first expansion, then 9x squared minus 132x plus 484. Then this r squared I will move to the left hand side, because minus r squared equals to 0. And then now, okay, so actually the difference is just the constant, because just now you were given 85, right? So you move that. So therefore the difference will be just a constant. So it means that I will rewrite these two terms. So I will be getting 10x squared minus 130x. When I simplify the new equation now. So I will write 10x squared minus 130x. And then I just need to recalculate my constant. So 1 plus 484, it will be 485, then minus r squared. That will be my new constant. Alright, and now in the question is mentioned that the line is a tangent. So when tangent means that there's only one intersection point. So which means the discriminant is 0. Right? So now from here my A is 10, my B is negative 130, my C is 485 minus r squared. So now my B squared minus 4AC equals to 0 because of tangent. Okay, then now just replace all the values. And then you let it be 0. Now I do expansion. Square of 130 is basically 16900. Then here is negative 40, so you multiply. So when you multiply, you will get negative 19400. Then this negative 40 multiplied with minus r squared is plus 40 r squared equals to 0. Then from here, the first two terms, when you simplify, you will be getting negative 2500 and then plus 40 r squared equals to 0. Then from here, 40 r squared is 2500. So your r squared is going to be 2500 divided by 40. At last, you'll be getting 125 over 2. Now, we do not need to find what is the r, because our equation, okay, needs r squared. Alright, then now we have found the r squared, just replace it and you'll be getting the new circle equation. So now from 1, okay, equation of the circle, it will be x plus 1 squared plus y minus 2 squared equals to 125 over 2. So that's the equation of the new circle. Okay, now question number 7a. Show that the minus of these two terms equals to 4 over 5 cos squared theta minus 4. So I will start from the left hand side because it is more complicated compared to the right hand side. So this is going to be, now getting the same denominator means that you do cross multiplication. So it will be cos theta minus 2 sin theta multiply with cos theta plus 2 sin theta. So it looks like cross multiplication. Okay, then here I will get sine theta plus 2 cos theta multiplied with cos theta plus 2 sine theta for the first term. Okay, then minus, there's a minus here. Then sine theta minus 2 cos theta multiplied with cos theta minus 2 sine theta. Alright, so now what we need to do here is we just need to do expansion and simplify the terms. So I will write here. Now we just do one by one. Sine theta times the whole bracket followed by the 2 cos theta times the whole bracket. Then you will get sine theta cos theta plus sine theta times 2 sine theta is 2 sine squared theta. Then the 2 cos theta times cos theta, it will be 2 cos squared theta. So the 2 cos times 2 sine, it will be 4 sine theta cos theta. Okay, and same goes to the next expansion. Just do expansion here. After that, the negative 2 cos multiply. Right, so cos theta times sine theta times cos theta, I will get sine theta cos theta. Then the sine times minus 2 sine, it will be negative 2 sine squared theta. And negative 2 cos times cos, it will be negative 2 cos squared theta. And lastly, minus 2 cos times minus 2 sine, it will be plus 4 sine theta cos theta. Okay, so close bracket. Now, for the bottom, the denominator, we have a formula. A minus b times a plus b is basically a squared minus b squared. So this is my a, this is b, this is a, this is b. Therefore, I will be getting a squared minus b squared, which means it will be cos squared theta minus square of 2 sine theta. Okay. Though now I need to simplify because we need to get 4 over 5 cos squared theta minus 4. So now when you simplify, okay, we open the bracket. Let me just rewrite all the terms. I will get sine theta cos theta. Now, these two terms, we can factorize the 2. It will be sine squared theta plus cos squared theta. And then when I look at the question here, this is 4 sine theta cos theta. This is 1 sine theta cos theta. I simplify it to be 5. Okay, then this minus you bring in. At the same time, when you look at here, sine theta cos theta plus 4 sine theta cos theta, it will be 5 sine theta cos theta. Together with the minus, it will be minus 5 sine theta cos theta. Okay, and then when you look at the next term, when I bring in the minus, this is plus, and the 2 is in common. Therefore, I will write plus 2 bracket sine squared theta plus cos squared theta. Okay, then over. Now, I will be getting cos squared theta minus 4 sine squared theta. Now, for the numerator, obviously, the sine cos can be cancelled off. Alright, and then left these two terms. So it will be 4 of sine squared theta plus cos squared theta. Now, for your information, sine squared theta plus cos squared theta from the identity, it is 1. Then I will say that this is basically 2 times 1 plus 2 times 1 over. Now, when we look at the question here, we need cos squared theta in the denominator. We do not need the sine squared. So now I have to change. So according to this identity, sine squared theta is 1 minus cos squared theta. So I will get cos squared theta minus 4 bracket 1 minus cos squared theta. Okay, then now my numerator is 4. Then now my denominator, just do the expansion. Just do expansion. Then I will get cos squared theta. So minus 4 times 1 is minus 4. Minus 4 times minus cos squared is plus 4 cos squared theta. So now look at the given answer. You need 5 cos squared theta minus 4. So which means now I will get 4 over cos squared theta plus 4 cos squared theta. It is 5 cos squared theta. Then minus 4. Okay, so with this I have shown the identity. Okay, so done for the first part. Now B, hence means use the previous answer. Solve. Now these two terms are actually same as the left hand side of the previous term. Okay, exactly the same. So now I know that these two terms can be replaced by 4 over 5 cos squared theta minus 4. So I will just replace these two terms by the right hand side, then equals to 5. I just need to solve the right hand side equals to 5 for theta between 0 and 180 degrees. So here I will write 4 over 5 cos squared theta minus 4 equals to 5. Okay, so now just times or just move the denominator to the right side. So I get 4 equals to 5 times 5 cos squared theta minus 4. Then here you will be getting 25 cos theta minus 20 equals to 4. And now we need to find the theta between 0 and 180 degrees. So now I will get 25 cos squared theta. This minus 20 move to the other side becomes 24. Then now my cos squared theta is going to be 24 over 25. Hence my cos theta will be plus minus square root of 24 over 25. Okay, now by looking at the theta value, which means now we only consider first and second quadrant. Okay, and since your cos theta is plus and minus, means that your angle will be, this is the first angle and this is the second angle. Now I need to find the basic angle from, sorry. Now I need to find the basic angle from the calculator, which means this basic angle is inverse cos square root of 24 over 25. Then this basic angle is 11.5. This is also 11.5. Okay, so from here I will get my first angle is 11.5 degrees and my second angle is this major angle, this big one. Therefore, it is going to be 180 degrees minus 11.5 degrees, and at last you will be getting 11.5 degrees and 168.5 degrees. That's the solution of part B. Okay, now next question, number 8. The diagram shows a circle. This is a circle equation. The chord AB of the circles intersect the positive y-axis at A and parallel to x-axis. So now this is a chord. Okay, now find by calculation the coordinates of A and B. So basically you can just find the A by letting x be 0. Okay, because it is intersecting at the y-axis. So now I will rewrite my equation of the circle. So I will write at A, the x equals to 0. Therefore, 0 minus 2 is minus 2. Then squared plus y squared is 8. So this is 4 plus y squared is 8. Y squared is going to be 4. Your y is plus minus 2. But then when you refer to the diagram, obviously the y is above, is positive because it's above the x-axis. So therefore, so now I will write this. Therefore, your y is 2. So I have found the A with coordinates 0, 2. Okay, now if the A is with coordinates 0, 2, that means the y is 2, which means at the point B, the y is also 2. Okay, so now at B, the y is 2. And now I just need to substitute this y equals 2 into the circle equation. So x minus 2 squared plus 2 squared equals to 8. So x minus 2 squared plus 4 equals to 8. That means x minus 2 square is 4. So now x minus 2 is plus minus square root 4, which is plus minus 2. So now x minus 2 equals to 2, or x minus 2 is minus 2. Alright, two possible answers. So when x minus 2 equals to 2 means that your x is 4. But then for the other one, x will be 0. This is not possible. So omitted. Okay, so it's not possible for the b, because obviously when you refer to b, the b is with greater than 0 x, right? When the x equals to 0, that is the point A. So from here, I will get my b with coordinates 4, 2. Alright? So therefore, I will just write A is 0, 2. And the b with coordinates 4, 2. Alright, so that's all for this question. Now, find the volume of revolution when the shaded segment bounded by the circle and the chord AB is rotated through 360 degrees about the x-axis. Okay, so let's look at the diagram. You are rotating this about the x-axis for 360 degrees. So now, what I need to do here is I have to, when I do integration, okay, integration of this circle equation, basically I'm getting the, let's say this is the A, okay, I'm getting everything here up to here, right? I'm getting all, means here, 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 together with this. That will be the solid. But then now I know that if I integrate, then I have extra these two parts. Then I have to minus back. These two parts is basically a cylinder, right? When you rotate. So it means that I integrate the whole graph from A to B. Then I have to minus the area, the volume of the cylinder. Alright, so just now we have found at point B, the x is 4. So here is the 4. So which means for the cylinder, right, the volume of cylinder is pi r square h. So the h here is this value, which is 4. Alright, then the r is 2, because from 0 to A, it is 2. Okay, so now I will integrate the y squared from the circle equation, and the x, my volume will be pi integrate y squared dx, and then the x from 0 to 4. Then I will find all this. Then I have to minus the volume of the cylinder using this formula. Right, so now from the circle equation, x plus 2 square plus y square equals to 8. Therefore, from here, my y square is going to be 8 minus x minus 2 squared. Alright, so now my volume of the shaded region, or I just write volume, that's it. Volume equals to pi integrates from 0 to 4 y square dx minus pi r square h. Alright, so now this is going to be pi 0 to 4. My y square is this, so 8 minus x minus 2 squared dx, and then pi r square h, that is the area, volume of the cylinder, so minus pi. Just now I have explained the r is basically 2. Okay, the h is 4. So here is going to be 2 squared times 4. Then now I will just do integration. So I will be using this method, this formula. So integrate ax plus b degree n dx equals to ax plus b to the degree of n plus 1 over n plus 1. And then differentiate ax plus b is a together with plus c. But now here we do plus c because we have limits. Now I will write pi integrate 8 with respect to x, it is 8x minus x minus 2 degree 3, okay, because f is 2 now becomes plus 1. Remember, this formula is valid when the n is not minus 1. It can be for any other n. Then over 3, now differentiate x minus 2 is basically 1. Because the 1 comes from the x. Alright, so the limits from 0 to 4. Then minus 2 squared is 4. 4 times 4, 16. So I have to minus 16 pi later on. So now I will replace the x by 4 first. Okay, replace by 4 first. So 8 times 4 is basically 32. Minus 4 minus 2 is 2 cubed over 3. Then I minus when the x goes to 0. So first term is 0. Second term is not 0. Okay. So 0 minus 2, I get minus 2 cubed over 3. Then minus 16 pi. Okay. So now just need to calculate all the values and you'll be getting the answer very soon. So here it will be pi. Alright. So when you calculate all these values, all this, just open the brackets, you'll be getting 80 over 3. So I will write 80 over 3 here. Minus 16 pi. So at last, you will be getting 32 over 3 pi. So that's the volume of the shaded region after you have rotated it through 360 degrees about the x-axis. Okay, now question number 9. Function f, g, h are defined as follows. Okay, solve the equation fx equals to 0, giving your solutions in this form where a, b, c are integers. So fx equals to 0, which means x minus, this is square root, okay? So 4 square root x plus 1 equals to 0. So to solve this, I will move the 4 square root x, the negative 4 square root x to the other side. Then here left, x plus 1 equals to 4 square root x. And then my next step is going to be square both sides because I don't want the square root. So when you square both sides, it will be x squared plus 2x plus 1. Right hand side, square of 4 is 16. Square of square root x is just x. And then now just move all the terms to the left hand side. I get x squared plus 2x plus 1 minus 16x equals to 0. At last you get x squared. 2x minus 16x is negative 14x. Then plus 1 equals to 0. Now in order to get this form, obviously you have to solve using quadratic formula. So now I will write down my a is 1, b is negative 14, c is 1. Now if you refer to the quadratic equation ax squared plus bx plus c equals to 0, the quadratic formula is x equals to minus b plus minus square root of b squared minus 4ac over 2a. So now here I will get x equals to minus b is negative 14, plus minus square root of b squared minus 4ac over 2a. Alright, so minus 14 is positive 14, plus minus, when you calculate square of minus 14 minus 4, it will be 192. Then divided by 2. So here I have to simplify to get this form. Therefore, 14 plus minus square root 192 is basically 8 square root 3. Then over 2. Okay, so now I split into two terms. It will be 14 over 2, I get 7. The 8 square root 3 divided by 2 is 4 square root 3. Okay, so let's look at the question. It is plus because your x is greater and equals to 0. So you cannot accept the weight. Okay, now when you check 7 minus 4 square root 3 is still positive. Right, still positive. Therefore, that's your answer. You just need to make sure that these two values are positive. So since now both positive, then that's the solution of this question. Okay, now part B. Given that fx equals to or equivalent to ghx, find the values of m and n. Now, firstly, I have to find what is my ghx. It will be g of hx. Where is the hx? Ghx is the composite function. Hx is square root x minus 2. So here I will write square root x minus 2. Now, your gx from the question, it is mx squared plus n. So here I will write mx squared plus n. Right? Now, when you compare, your x now has been changed to these two terms, which means I have to change this x to these two terms as well. So which means it will be m of square root x minus 2. This is my new x, then you square it, plus n. So I will do expansion first. It will be m of square root x is x, then minus 4 square root x plus 4, then plus n, and I will do expansion. You will get mx minus 4 square root x m, or I will say 4m square root x, that will be better, plus 4m plus n. Okay, I have found the right hand side. Now you have to write fx equals to the composite function. So now my fx, refer back to previous term or previous part, it will be x minus 4 square root x plus 1. So now here I will write x minus 4 square root x plus 1 equals to mx minus 4m square root x plus 4m plus n. And now we need to find the values of m and n. So obviously I can compare. So now by comparing, right, the left and right side, so here m equals to 1. Okay, so now m equals to 1. Or you can compare the second term. Minus 4 square root x equals to minus 4m square root x, means that the m is also 1. Then after that, 1, compare the constant. So 1 equals to 4m plus n. So now 1 equals to 4 times 1 plus n. That means the n is 1 minus 4, which is minus 3. Okay, therefore my m is 1, the n is minus 3. So that's the solution of this question. Now, question number 10. The diagram shows the circle with center A, radius 5. Okay, here is 5. And a circle with center B, radius 8. That means here is 8 as well. The circle touch at the point C so that ACB is a straight line. So ACB is a straight line. The tangent at the point D, here, tangent, this is a tangent, on the smaller circle intersects the larger circle at E and passes through B. Find the perimeter of the shaded region. So to get the perimeter of the shaded region, basically we need to know what is the arc length of DC, arc length of CE, and the straight line DE. Okay, but unfortunately the angle and none of the angle is given. So from here I can find angle BAD. So BAD or CAD, I need to find this angle first. Okay, so this angle, look at the right angle triangle here. Right, so when you need to find this angle CAD or DAC, you are given this is right angle, that means this is adjacent side. Okay, adjacent side, and this is the hypotenuse, right? So 8 plus 5 is 13. So now from here I have adjacent and hypotenuse, that means that is cos. Okay, so I will write cos angle BAD or CAD, right, up to you, equals to 5 over 5 plus 8, which is 5 over 13. So now angle BAD equals to 1.1760. You take the inverse cos. Alright, so now I have found the angle. So then I know that the other angle, because this is 1.1760, then I can find angle here. Right, because I need to find the arc length of CE. So this angle is going to be pi over 2, because the total of these two will be pi over 2 minus 1.1760. So that is my angle DBA. it will be pi over 2 minus 1.1760, and that will be 0.3948. So here I found this angle is 0.3948. Okay, then I can find the arc length later on for these two sectors. And then now I need to find what is my DE. So my DE can be found if I know what is this, right? So from here, I can use a Pythagoras theorem. Since I know these two sides, the hypotenuse is 13. So the DB is hypotenuse square root of hypotenuse square minus 5 squared. So now my DB is square root of 13 square minus 5 squared, which is 12. Therefore, I can find what is my DE, because the total here is 12. So obviously the DE is 12 minus 8. So now DE is 12 minus 8, which is 4. So with this, I can find my perimeter of the shaded region. Okay, so arc length formula is this. Let's say here's theta, this is r. So the arc length is theta r. Okay, so I just need to get the multiplication of 1.167 with 5 and 0.3948 with 8, right? Then plus with the DE. Then I will get the answer. So means that I will be getting 1.1760 times 5 plus 0.3948 times 8, then I plus 4. Then you will be getting 13.0. So that is the perimeter. Then I will just write centimeter here. Okay, so done for the perimeter of the shaded region. Now find the area of the shaded region. So area can be found by using area of triangle, okay, minus area of these two sectors. So area of triangle, since this is 90 degrees, right angle triangle, so I can just use half times height, which is 12, and the base. Then minus these two area of the sectors, right? So now I will get area of shaded region equals to half times 5 times 12 minus, okay, now go back to the sector. This is r, here is theta. Area of the sector is half r squared theta. Okay, so therefore from here I will get half, my r is 5, the theta is 0.1, sorry, the theta is, look at the previous question, 1.1760 and 0.3948. So here is going to be 1.1. So here 1.1760 plus half of 8 squared, then 0.3948. Then now when you calculate this, it will be 30 minus, the first one is going to be 14.7 and the second is 12.6336. Then now at last you will get 2.6664, and now I round up to 3 significant figures, it will be 2.67. So that's the area of the shaded region. Now for question 11, is given that y equals to k times 3x minus 1 to the power of negative 1 plus 3x. This is your y. Find in terms of k the values of x at which there is a stationary point. So stationary points means dy dx equals to 0. Alright, so now I will rewrite my y. So now dy over dx. Since k is a constant, remain the constant, and now I'm going to differentiate using the power rule. So that means you need to bring down the n, rewrite the function, degree becomes -1, and differentiate the fx. Right? So now I will bring down the -1, rewrite the function, the degree you -1, so -1 -1 becomes -2, and now when I differentiate 3x minus k, it will be 3. So the last term, differentiate 3x, it will be another +3. So now here I will simplify. So k times -1 times 3, it will be -3k. And there is a power of -2 for the bracket. So I will write over 3x minus k, the whole term degree -2. Degree +2 because I already moved down the function. Then +3. This is the dy dx. So stationary points means dy dx equals to 0. Which means now 0 is -3k over 3x minus k squared, then +3. So I will move this whole term to the left hand side. So it becomes 3k over 3x minus k to the power of 2 equals to 3. And now you need to find x. Okay, so this whole denominator move up. I will get 3k equals to 3 of 3x minus k squared. Now, the 3 from both sides can be cancelled off. Okay, then now I will, because we need to find x, no need to do expansion. So I will just write k equals to 3x minus k squared. Then for the squared, right, so instead of writing this, I will just swap the positions, right? So 3x minus k squared equals to k. I need to find the x. Now I will move the squared to the other side, becomes plus minus square root of k. So 3x minus k is plus minus square root of k. Then from here, right, my 3x, move the k to the other side. So k plus minus square root k. So my x is going to be k plus minus square root k over 3. That's my x value. Okay, find the values of x at which there is a stationary point. So that's the solution of this question. Now, the function f has a stationary value at x equals to a. So it means that your stationary point is at x equals to a, and defined as fx equals to this for x greater equals to 3 over 2. Now, b, find the value of a and determine the nature of the stationary value. Okay, so now I will compare this function with the previous function. Alright, because they are similar. So I will write compare fx equals to 4 bracket 3x minus 4 to the power of -1 plus 3x with fx equals to k bracket 3x minus k to the power of -1 plus 3x. So from here we found that the k is basically 4. Okay, now it's mentioned that the stationary value at x equals to a. So for the previous one, okay, so from first, we have found the dy dx when dy dx equals to 0. We have solved this in previous part. The x is plus k plus minus square root k over 3. Okay, so now when you compare with the new function here, our k is to be replaced by 4. So from here, okay, let's say this is the second one, right? Or I would just say this is the first, this is the second. So now, from first equation, right? dy dx equals to 0 when x equals to a. So now I will just substitute the result into this. Okay, so now my a is going to be, let's say this is a third equation. So I will write from third, my a is going to be 4 plus minus square root 4 over 3. Then I will get 4 plus minus 2 over 3, because the square root 4 is 3. Then here is going to be 4 plus 2 over 3, or 4 minus 2 over 3. The first one will be 6 over 3, which is 2. The second one is 2 over 3. That will be your a. But then, look at the x. The x is the a. So your x is at least 3 over 2. Okay? So, given x is at least 3 over 2, which means your a must be 2, because 2 over 3 is less than 3 over 2. That's your final answer. Okay, now see, the function g is defined by this, where x is greater and equals to 0. That means making your reasoning clear whether g is an increasing function, a decreasing function, or neither. Now, increasing function means the differentiation is greater than 0. Okay, g prime x greater than 0. Decreasing function means g prime x less than 0. So now again, when I compare this with my the basic form, obviously now your k is minus 1. Okay, so I will write compare gx equals to negative of 3x plus 1 to the power of negative 1 plus 3x with y equals to negative k, not negative k, is k just now. Okay, when you refer back to the second equation over here, it is k. So I will write, this is k bracket 3x plus, is it plus k? Sorry, it's minus k. Okay, minus k power negative 1 plus 3x. So I will get the conclusion of k is basically minus 1. Okay, so now from a, right, when y equals to k of 3x minus k to the power of minus 1 plus 3x, our dy dx, we have done the dy dx here. So go back to the part A, the dy dx is this, right? So I will copy this expression. So it will be negative 3k over 3x minus k squared plus 3. And then now I know that my k is going to be minus 1. So when k equals to minus 1, I will be getting dg over dx. Okay, or g prime x, I would say g prime x is going to be negative 3 times negative 1, because k is minus 1, then 3x minus 1 squared plus 3. Then this becomes 3 over 3x plus 1 squared plus 3. Okay, so now you need to conclude whether this value is greater than 0, less than 0, or not both, right? So look at the x here. The x is at least 0. Okay, so now I will just explain it here because I want to show you this. So you can just write for gx, the x is at least 0. So now when you look at here, 3x plus 1, right? Or I would say, I do it step by step. 3x is definitely at least 0 because you times by 3 times 0 is 0. Then now my 3x plus 1 . Okay, hang on please. So here 3x plus 1, it will be greater or equals to 1 because your 3x at least 0. 0 plus 1 is at least 1. Therefore, now for this whole term, right? So when you square it, definitely is greater at least 1. So now my 3 over 3x plus 1 squared will be at least 3 because you multiply by 3 or 3 divided by 1. So then 3 plus 3. So now my g prime x is 3 over 3x plus 1 squared then plus 3. Definitely this is at least 3 plus 3, which means at least 6. So when at least 6, then I will write since g prime x greater than 0, then gx is an increasing function because my gradient is at least 6. Okay, so that's the solution for this question. Alright, so we have come to the end of the video. Thanks for watching. So if you enjoy watching my video, please subscribe to my channel and recommend it to your friends. And not to forget to stay tuned for more upcoming videos. Thank you. Bye.